Hello, and welcome to the concluding event of WMPD Day. It is, as you, I'm sure you know, a seminar focused on, a session focused on understanding diversity in STEM. This event is sponsored by the Center for Advanced Study in Behavioral Sciences at Stanford and by Sage Publishing Company. My name is Claude Steele. I am the Lucy Stearns Professor Emeritus of Psychology at Stanford University, and I will be the moderator for today's sessions. I should note that the National Science Foundation has been involved in monitoring the degree to which women, minorities, and persons with disabilities populate the STEM fields for a good number of years now. And today's event coincides with the release of its newest report on those statistics, a report prepared by the National Center for Science and Engineering Statistics. I am, in discussing these issues in this report today, I am joined by several colleagues, sociologist Aaron Check, psychologist Mary Murphy, and education researcher Naila Nazir, in examining the gist of these findings and some of the strategies that they will spur us into doing, we hope. I will introduce each speaker at this point in the session very briefly. They will give 5 to 7 minute presentations of their work, and then we will open it up to a broad question and answer and discussion session for the rest of the hour. So I will begin with Aaron Seck, who is an assistant professor in the Department of Sociology and the Department of Mechanical Engineering at the University of Michigan. Her work on inequality in STEM professions focuses on the recruitment and retention of women, people of color, LGBTQ identifying persons in STEM degree programs and in STEM jobs. Mary Murphy is the Herman B. Wells Professor of Psychological and Brain Sciences at Indiana University. Her educational research illuminates the situational cues that influence students' academic motivation and achievement, with an emphasis on understanding when those processes are similar and different for structurally advantaged and disadvantaged students. Her organizational research, meanwhile, examines barriers and solutions for increasing gender and racial diversity in STEM fields. Naila Nazir is the 6th president of the Spencer Foundation, which funds educational research nationally. She has held a faculty appointment in education and African American studies at the University of California, Berkeley, where we worked together for a while, where she served as the chair of African American studies and later as the vice chancellor for equity and inclusion at that university. She is also the current president of the American Educational Research Association. Naila's research examines the racialized and cultural nature of learning and schooling, with particular focus on the experiences of African American students in schools and communities. Before I turn it over to Naila, who will be the first of our speakers, I wanted to note that there will be a ample question and answer session after the speakers have spoken. But if you have questions, and if you have questions for those, please use the question and answer function of Zoom. The chat function is disabled for particular reasons, so I am to guide you to use the question and answer section of Zoom. And this event is being recorded, and you will be able to view it later on socialsciencespace.com. So with those remarks, I can turn it over to my good friend Naila.
Great, thank you. Yeah, so Claude was my boss. That's how we work together. Anyway, wonderful to be here with such amazing colleagues and a part of this important conversation. So I think I go first because I'm going to do kind of some broad framing about what the issues are around diversity in STEM, and in particular how we think about the racialized and cultural nature of learning and how that shows up in STEM spaces and other classroom spaces. So I'm going to share my slides. Make sure I can see that. So As a learning scientist, I've studied a wide range of learning settings with an eye towards understanding the racialized and cultural nature of learning. And one thing I very much appreciated about this session and the report is that it's both about barriers, but I think in the background there is a conversation about possibility, right? About what we can do differently, how we can transform teaching and learning experiences in STEM that really do serve all students. And I think that's important because one of the things we know from the research that we see again and again and again and again is the dismal experience that many racialized, racially minoritized students, as well as women, and in some contexts, and students with disabilities, have in schools at all levels. Experiences that not only fail to develop their potential, but that do so en masse, leaving whole generations of intellectual and innovative potential on the table for students. And this is even more extreme in STEM in particular, with access to high quality, rigorous STEM teaching and learning quite unevenly distributed by race, social class, gender, and disability status. And some of these trends and the outcomes that they create are documented in the report. And so when we think about learning, right, we all learn and develop in relation to our environment, our experiences, and our relationships. And so one of the things that happens in schools for racially minoritized students is that they consistently get messages that they do not belong, that they are not smart, and that they are not learners. These messages are quite common in STEM in particular, where too often math and science learning is viewed as the purview of some, but not all. And these experiences of inequality drive effort, engagement, and outcomes. Context sends all kinds of messages to students about what's possible for them and what spaces they belong to. And so we know a lot about learning from the most recent science of learning, things we didn't know 20 or 30 years ago, right? As I mentioned, we know that experiences, environments, and relationships are defining for learning and development. We know that learning is integrated with emotion, with cognition, and the formation of identity, that those things happen together. You can't separate them out and just deal with the mind alone, right? And Mary will talk a lot more about that. We know that strong and trusting relationships are central to learning. You can't learn in places where you're not connected to the people around them, or learning is more difficult in those places. And we know that learning is shaped through culturally organized activities of everyday life and across the lifespan. So it happens everywhere. And that people make meaning by reflecting on the connections between new information and existing information. So in other words, learning doesn't just happen inside of our heads, and we can't set aside our sense of self, our emotional needs, or our life experiences as we engage in learning settings. That being said, cultural practices, everyday knowledge and experience, racial and cultural identity, as well as gender identity, are integral to learning and to designing effective learning environments. And so what does this suggest about what we need to create? And I think about these characteristics really as across the lifespan. So whether you're talking about early childhood environments or K-12 environments or higher ed environments, you need environments that affirm students culturally through the curriculum and through the interactions, where environments are designed to meet learners' developmental needs, whatever those may be, whether that's emerging adulthood or early childhood. Environments that create opportunities for belonging, that take a positive approach to classroom management and discipline. And you need relationships. Those environments need to be centered in a collaborative approach to learning, pedagogy that's rooted in love and care for the learners, communities that have multi-layered relationships, so peers you can go to, instructors you can go to, and that prioritize teacher-learner relationships. And then you need particular kinds of experiences, right? Experiences that support racial, gender, and other identities, where there's modeling and critical reflection, where there's a supportive professional community of teachers or instructors that share equity goals and values, and where there are interactions that affirm positive characteristics and futures. And so while that's about the learning spaces themselves, those learning spaces actually only happen that way when they're set within systems that are fundamentally designed for equity. And so in order to support learning, you need systems, and K-12 that might mean district level shared goals and strategies, whole school values, the teacher pipeline and professional development considerations, and thinking about policy structures and interactions that affirm and create belonging. So just wanted to signal there that it's both about what happens in those specific classroom environments, but also how we set up the broader systems within which learners learn. And I will end there and pass to my colleague. I don't remember who I'm passing to, and I can't think and exit
Aaron.
these slides all at the same time.
The baton goes next to Aaron.
I will pass to my colleague, Erin.
Wonderful, thank you. I will take the baton and express my gratitude for that really wonderful overview of educational processes and how we can structure things to better support students. I am going to talk about the importance of thinking about not only inequality in STEM intersectionally, but also thinking about how privilege plays out in this context, in addition to thinking about disadvantage. So just a quick note that a lot of this work that I'll flag is funded by the National Science Foundation, and I'm certainly grateful for their support for that. So the kind of paradigm of doing research in inequality in STEM has to do generally with focus on single axes of disadvantage. A lot of my previous research has done this, and there's been really important headway made in understanding how race and gender inequality manifest within the context of STEM education, as well as in STEM workforce contexts. But there's been less attention to other marginalized and minoritized populations and experiences. So experiences are persons with disabilities is a space that has received much less attention vis-a-vis other axes of difference. And then there's different identity categories that are left out of data collection entirely. So one of the things that I have talked about in terms of NCSES data is the need for inclusion of LGBTQ identity and broader gender identity focus. In some of my research that was co-collected or analyzed with Tom Waits-Eunice, we actually had to collect our own data to be able to understand LGBTQ inequality. And in a survey of STEM professionals of over 25,000 of them, we found that LGBTQ STEM professionals experienced things like professional devaluation and marginalization, and even higher turnover intentions than otherwise similar non-LGBTQ persons, but that we couldn't actually see these disadvantages without having the data to look at them. So first and foremost is a call to make sure that we have data from places like the National Science Foundation that actually allows us to see these patterns of disadvantage emerging. But beyond the differing categories that's important to flag, another piece to consider is the way that these experiences are interwoven intersectionally. So for those of you who are unfamiliar with this concept, intersectionality is the critical study of how multiple social systems intersect to produce and sustain interwoven complex inequalities. So we can't, for example, think about gender inequality and race inequality in STEM as somehow separate entities, but rather these things are interwoven in really important and powerful ways. So intersectionality emerges, of course, out of the work of Black feminist theory and social justice critiques, and really challenges us to push for understanding power relations and the complexity and relationality of these kinds of disadvantages. And so that we're not just focusing on differences in intersecting identity categories, but really questioning and critiquing the underlying structural and cultural systems that lead to what Crenshaw and others have called the matrix of domination. So I'm going to present some early results from a project I'm working on now that looks at the sort of intersecting privilege and disadvantage by gender, race, LGBTQ status, and disability status. So this is just an example of one of many types of disadvantages I'm looking at, but this particular question asked respondents whether they had been harassed verbally or in writing on the job in the last 2 years. And what I've done is actually broken out these results by 32 gender, by LGBTQ status, by race ethnicity, by disability status categories, and then normed everything against the values for heterosexual white men without disabilities. And what I find is that compared to heterosexual white men without disabilities, individuals in every other gender, by race, ethnicity, by LGBTQ status category report higher frequency of experiences of harassment. What this points out, importantly, is that we need to think about privilege, not just experiences of disadvantage, when trying to disentangle these mechanisms of inequality. And so the work that I'm engaged in now is focused on understanding the mechanisms that might maintain that privilege. So asking whether heterosexual white men without disabilities might enjoy what I call privilege premiums. So privileges that can't be explained away by differences in human capital or employment or work effort or family circumstances, but rather are a benefit of the kinds of socio-demographic status that they have. But in order to understand what's going on with these privilege premiums, we can't just focus on white heterosexual men without disabilities as being just spared from sexist, racist, ableist, homophobic circumstances, which they certainly are. But in addition to that, the kinds of cultural processes in STEM that help to support and maintain that privilege. So much of my work has been asking questions about the professional culture of STEM, the sort of beliefs and practices that swirl around within STEM that might promote this kind of privilege, but kind of be seen by people in STEM as sort of benign or neutral. A couple of examples of these are, first and foremost, the ideology of depoliticization. And I define this as the belief that STEM not only can be separated out from political and cultural concerns, but should be. That the only way to do pure STEM is to bracket those things as much as possible. But of course, STEM is a human endeavor, and so is already culturally and socially constructed. And so the ideology of depoliticization actually just promotes the privilege of heterosexual white men without disabilities, because it silences conversations about exclusion and marginalization and devaluation. The final cultural process that I'll speak about is what I call schemas of scientific excellence. And this is the cultural yardstick that we use to measure up members of our profession as competent or excellent. And this yardstick has characteristics and skills that are assumed to be markers of that excellence. But as we know, that yardstick is warped by different social biases. And so even though that schema might seem neutral or objective as a judgment of excellence, every time we measure someone up, we introduce biases into that judgment, except for those who experience that privilege. So I will say, from my vantage point looking forward, some things to consider are as follows. First, that inequality in STEM research should consider intersectional processes that are inclusive of a broader range of axes of disadvantage than we even have statistical data for currently. And additionally, that we have to consider mechanisms of privilege as well as marginalization and devaluation. And with that, I will hand it over to Mary.
Wow, that was incredible. Thank you both. Let me share my screen here. All right. Well, I'm going to discuss for my time a barrier and what I think of as an important lever for change. And that is this role of faculty, institutional, and disciplinary mindset. So what you might know about mindset is sort of the work of the past 25 years that has really thought about mindset and the way that Carol Dweck and others have operationalized it, thinking about the fixed mindset as sort of this belief you either have it or you don't. You have the innate talent, ability, drive, to do a particular thing, to become a math person, to be a math person or not. And then the growth mindset, which is this idea that talent, ability, intelligence is something that you develop. It's a potential, and that there are things you can do in order to grow that potential over time. Now, the work that most people are familiar with when it comes to mindset is done at the individual level, really thinking about mindset as a quality of individuals' beliefs, right? And it's focused a lot on students, where it's like, what's the student's mindset? And what we have seen as an unfortunate consequence of that focus is that many students in our classrooms, this goes all the way up to college and even beyond when it comes to who we decide to hire into the professorate and who we decide to promote, we tend to label people. This person just has a fit, I hear teachers doing this unintentionally often, this student just has a fixed mindset. There's nothing I can do about it. It's become a label that then, follows the student throughout their life trajectory. And for the last 10 years or so, since a first paper that we published in 2010, we really started to reconceptualize this idea of mindset, to think about it not as a quality inside people's head, but as a cultural variable that exists in the environment in which students and others are enacting on a day-to-day basis. So we're thinking about organizational and institutional mindsets. And in particular, we've done a lot of work thinking about how different scientific disciplines communicate these beliefs about people's potential and their ability. Is it fixed, or is it something that grows? Is it a potential? And we see indices of this all over the place, and from the awards that actually only allow us to nominate one individual, the genius of the project, right? For things like MacArthur Genius Awards, for example, when we know that some of the science has been done in collaboration or in teams and that sort of thing. Tenure and promotion criteria that really suggest that we can distinguish an individual's contribution and really valuing individual contributions, right? That there's this like genius out there and we need to identify a person's level of genius in their work. Also, this idea of authorship order, right? And just counting up the number of first author publications is another structural way in which different disciplines communicate what's valued, what is seen as important. And then also, I would say funding. So we see in the report released today that different kinds of students receive different levels of funding for their graduate education. And that really communicates which types of students are literally worth investing in when it comes to their potential over time. So, these different scientific disciplines communicate either these cultures of genius or these cultures of growth through the various acts of what they value and what they put forward. And what does this have to do with diversity in STEM? Well, we have been arguing and showing with data that these cultures of genius create a context of stereotype threat. They put people who are at risk of confirming negative stereotypes about their group because they belong to groups that are negatively stereotyped around ability, intelligence, and talent at risk in these contexts of having to disprove these stereotypes in addition to just doing their work on a day-to-day basis. How would we know that this happens, that cultures of genius, these fixed mindset cultures in science, actually create a context of stereotype threat? Well, you would expect to see that you'd see the same kind of outcomes associated with stereotype threat, but only or much more so in these fixed mindset contexts compared to the growth mindset context. And that might mean, women and people of color underperforming in these contexts, showing less motivation, engagement, desire to persist in these contexts. And you'd see that more in the fixed compared to the growth mindset context of STEM. So I want to show you a little bit of data that we've drawn on to really identify some of these processes happening. So this is one institution-wide study that had the entire STEM faculty participate, and we measured those STEM faculty's mindset beliefs about their students. To what extent can students learn the material important for your class, or do they just sort of have it or they don't, right? That sort of idea. Then we longitudinally, we collected data across all of their courses for 7 semesters. That ended up being over 600 courses at this institution with many, many students. And what we found here was that the racialized achievement outcome, there was a gap here, right? And the gap was twice as large in courses taught by faculty who self-reported fixed mindset beliefs. Now, another way to look at the interaction, of course, is to look at it this way, which is really, this is the unfortunate and reproducible gap that we often see in STEM contexts, learning environments. This is something to me that was very interesting and different, right? The fact that the racialized outcome gap was halved in courses taught by faculty who endorsed more growth mindset beliefs about their students. So what's happening in this class, in these classes, that's different than those fixed mindset contexts? Well, I'm going to get to that in just a moment. But we also need to understand how these faculty mindsets and the context that they're creating for these learning environments actually influence students on a day-to-day basis in their actual college classrooms. So in a different set of work, we actually looked at this across 4 universities and many different gateway STEM courses among many college students at the beginning of their college career. And we looked at this using a method called experience sampling that actually allows us to look in the moment in class how students are experiencing that particular STEM class that they're enrolled in. And what we found, just to get to the chase here, is that when students perceive their instructor to endorse more fixed mindset beliefs, this led to greater psychological vulnerability in the moment in that particular professor's class. It reduced their sense of belonging. It increased evaluative concerns. It made them feel like an imposter in that classroom, and they experienced more greater negative affect, not surprising given these other psychological effects. Now, I care about psychology as a psychologist, but many people say, why do we care about psychology? Well, it has a lot of important downstream impacts, right? So what we found in this study was that this faculty mindset and the psychological experiences that stemmed from those mindsets influenced students' course engagement, including their attendance in class, their dropout intentions, and the effort that they reported putting into class. It also lowers interest, but it has a particularly pernicious effect because it not only lowers interest in that particular class, that Chem 101 or that Bio 101 class, it actually had an impact on students' interest in the field as a whole. So it generalized outside of the classroom to make people less interested in chemistry as a whole or biology as a discipline. And then also replicating some of our previous work, we found that it was also associated with lower course performance in that particular class. And so, what can institutions do about this? What can we as society do about this? What can disciplines do about this? One of the suggestions that I want to make here is that we really attend to our mindset cultures in our disciplines and in our institutions and in our classroom context. So one project that is really focused on this in higher education has been a project I've been affiliated with called the Student Experience Project. And there we put forward a theory of change that these culturally inclusive growth mindset cultures are going to shape students' experience with learning, as we saw it in the previous graph, and that this affects students' cognition and motivation and their performance. And so what we're doing is we're working actually with 6 different institutions around the country. These are colleges and their entire STEM faculties. And we are engaging in particular education with faculty around the kinds of changes that actually create more of these culturally inclusive mindset cultures in their classroom. We give them access to a change library where they can download particular change ideas with examples and checklists. And then they get to see their own data broken up by different identity groups. So they can see how students are experiencing a sense of belonging in their classroom, for example, and how that might be different for women compared to men, or students of color compared to white students, or students with financial disadvantage compared to students who are financially advantaged. And this is all done in terms of transforming institutions. And so the institutions that are participating in this study are working together cross-institution wide to create these equitable supports and to learn from each other's work with their faculty on this. And students have been involved at every point of change. So students are really involved with what are the right practices to engage in the classroom, as well as how their data would be shared and looked at by faculty and in these working groups across time. So just to give you an example of what in this project we're working with faculty to change their culture, faculty get to see their own data like this, right? The percentage of students, for example, experiencing a sense of social belonging in the class and where their gaps might actually lie. And as they engage in the practice library, they get to see over time how those practices are shifting students' sense of belonging over time, for example. So we have provided in this project a practices library with concrete practices for change. And again, this kind of takes us outside of the student's head, as you can see, and into the classroom as a structural change enacted by the faculty, the culture creators of their environment. And so what have we seen from this project? Well, we just finished the first major cohort this past fall, and we've collected a second cohort this spring that's coming to an end for some of our quarter classes. They're not, quarter universities are not quite done yet. But what we saw at the end of fall was that every college's team, and that included 6 colleges and 100 instructors, were able to grow students' sense of belonging and identity safety in these Gateway STEM courses. And in fact, we saw many instructors improved Black and Latinx students' sense of belonging and identity safety by big margins, 20, 30 percentage points or more. And then finally, we're seeing innovation happening at the institutional level, such that these college teams are extending this learning to other areas. Yes, we're working in these STEM classrooms, but they're also seeing how these kinds of messages and practices can be engaged in other parts of the university's functions. Things like early alerts, design of the physical and virtual space, academic probation messaging, all using these kinds of automated tools that help them see what students perceive about these different messages in sort of A/B testing, or as we might call it, experiments, to really see how this shapes student experience. So I'll just conclude with saying that, this focus on this opportunity of this organizational mindset lens, institutional mindset lens, compared to an individual mindset lens, really affords a shift here to institutional and systemic and systemic transformation, rather than simply trying to change particular students' beliefs. And I think this is really one of the key pieces that we're going to need as we move forward to make progress on the remaining disparities that we see within STEM environments. And I think this is really in line with some of the things that Erin and Naila were sharing around who's smart, who's a learner, right? Who is skilled, and what those beliefs are. So I think this is nicely related. So I'll stop there and see where we are.
Thank you, Mary. Thanks all of you for wonderful talks and squeezing them so well into such a short period of time. But we had agreed beforehand that Mary, you might extend yours a little if you're willing to describe some of the highlights of the NSF report that you had a chance to look over. So
Right.
maybe just a few minutes of highlights, and then we'll go into the question and answer section.
Sure, and maybe there's like a bit of a discussion here around some of these things. So a few things that really stood out to me. One is that it's very clear that over time there's progress made, particularly when it comes to sort of the share of degrees awarded to individuals who are from structurally disadvantaged backgrounds here. But I also really noticed that the role of context matters. I think this gets to Naila's point around learning environments and Erin's point around who is assumed to be skilled in these contexts. Particularly, I noted that this role of HBCUs seems incredibly important for diversifying science and engineering in this country. So, I saw that 23% of Black graduates earning science and engineering degrees receive their degrees or earn their degrees at HBCUs. And they're clearly the overwhelming producer of success in this area. So I think there's a lot to learn from those learning contexts as we think about that. And I think many HBCUs have much of the characteristics that Naila shared with us. Do we want to talk about that, or do we want to move on to some of the other? I can point out sort of some of the key points, and then we can just discuss as desired. Maybe.
That sounds like a good strategy.
Okay. And then the next point that really stood out to me was really that, of course, we see that underrepresented minorities' share of degrees in science and engineering increased since 1999. That was sort of the high level point that was made, but still we see relatively small percentages of these individuals who are making it into the professorate. So much lower than their share of the population. At only 8.9% do we see underrepresented minorities being appointed to, say, academic positions. And this suggests to me that there is something about these disciplines and the structure of these disciplines at the highest level that are creating extra barriers for individuals, that there's a bit of a ceiling there. And the last point I'll make is this point about funding that I noticed, that students with disabilities who are going into science and engineering PhD programs are less likely to receive funding for those programs than those without disabilities. And that suggests to me sort of this fixed mindset belief about who's worth it to invest in, right? Quite literally. And so, you know, I don't know if others have ideas around this or want to tie their work to some of these points, but I think that there's serious links here around the data that's being shared today in the report.
Yeah. Wonderful. Well, I'm supposed to be getting questions at this point, and let me read one. How can I get a sense of my own degree of fixed or growth mindset as an educator? How can I get a sense of that? And what are some ways to help promote more of a growth mindset in the learning spaces I'm in? I guess that question would go to you, Mary.
Yeah, I think it's a great question to really start reflecting for ourselves about what our practices might be communicating to students. I mean, one of the things we encourage faculty to do is to really think through how their policies and practices from the very beginning, the first day of class, for example, are communicating whether or not this is a make it or break it, you have it or you don't kind of environment, or whether there is incentivized, perhaps, you know, the ability to make progress and to learn over time. So for example, one of the cues that really suggests to students that faculty have more of a fixed mindset is when there's simply a midterm and a final. Like put up or shut up. You either show me you have it or you don't, right? Versus other opportunities to get feedback over the course of the term or to self-grade oneself and to really see one's progress over time. The way in which outside resources are discussed when someone is struggling, the way that faculty talk about the first test, that almost everybody in these Gateway STEM courses are disappointed with their performance when the first test comes in college in a STEM class. How do you discuss that? Some faculty we've seen on videotape say, well, if you didn't do well in this first exam, maybe it's time to think about switching to a different class or to drop the class now, which communicates quite a fixed mindset, right? Or they say, if you didn't do as well as you wanted to, here are the strategies and the things I suggest you do to get better over time. Come see me, come to office hours, come to tutoring, these sorts of strategies that really help communicate that you believe in their ability to grow and develop. So these are just some of the ideas that we see students relying on to determine what their faculty's mindset is. And so as we look to what our own practices are, I think these are good places to start.
Great. Another question, takes off from Naila's remarks about the connection between the importance of relationships between learners and instructors and their environments in learning outcomes. So the questioner asked, could you all share an experience that you had where it was clear to you that the relationship of learners to their instructors made a significant difference in their outcomes, especially in progress in STEM?
Mm-hmm. Yeah, I think that's a great question. And I guess when I say relationships, part of what I'm signaling is connected to what Mary's been talking about, which is that students should feel like a member of a learning community. And that means many things, right? That means connections to the instructors where it is clear that they are viewed as intelligent, capable, valued members of the community, where their thinking and the development of their thinking is welcome and supported. That means relationships with peers where they are viewed also again as people who belong, as people who are valued in this space, as a space where people think together and where people learn together. Those things all reduce the push towards fixed mindset and encourage a kind of growth mindset space, and also create the kind of social, emotional, psychological environment where learning flourishes best. Many examples of what this looks like in practice, including a math department that I studied for many years, where they made it a really intentional practice to support students learning through collaborative group work. And that group work was about learning to think together and problem solve together to bring different types of cognitive, emotional, and other kinds of skills to bear on important conceptual mathematical problems, but also spaces where instructors are really intentional about conveying the value of a range of type of thinking in the classroom. And that those were classrooms that we were actually studying because of the stellar outcomes and the stellar equity outcomes that they produced. I don't know if anyone else wants to chime in there.
I can say,
Erin, you wanna,
Sorry.
Erin, go ahead.
Yeah,
You
I
wanna
was
pick
just
up on
gonna I was gonna echo that point, and I think what's so interesting about the issue about sort of fixed versus growth mindset is in fixed mindset there is a sense, as Mary said, they have it or they don't, but the it is socially constructed, right? So what we consider to be markers of excellence or competence within a field doesn't necessarily align with what's actually required of success in that field, and so that's some of this work on Schemas scientific excellence, that what we see as valuable, mathematical prowess and logical thinking, is really only part of what it takes to be successful in the context of STEM. It's sort of collaborative work and persistence and things like that, but those aren't recognized as the it factor, and therefore aren't part of the recognition of what is of seen as someone who is, you know, has what it takes by someone with a fixed mindset.
Yes, there's another very related question here about whether privilege sometimes leads to behaviors that seem like they're connected to STEM, like swagger and confidence and assuredness, that give you the impression that somebody knows a great deal, but may in fact not know so much. And can that make a difference? Can those kinds of things make a difference in the success and persistence of women, minorities, persons of disability, and so on?
Absolutely. And one of my favorite examples in the context of this research, and this is in a book that Mary Blair Loy and I are working on, is we took a sample of STEM faculty and we asked them what they thought were markers of excellence in their field. And one of the things that came up really often was assertive leadership. So risk-taking, being a strong leader, being sort of bragging about one's abilities. And we found that people who saw themselves with this assertive leadership characteristics actually earned more than their faculty colleagues who didn't, but they weren't any more productive. They didn't have higher grants, they didn't have more publications, and they weren't any more visible. So it's this sense of like what is seen as a marker of excellence and what actually translates into being productive in science.
Mm-hmm. Another question for you, Erin, is could you provide an example of schemas of scientific excellence?
Mm-hmm. Yeah, so the scheme of scientific excellence is sort of this compilation or constellation of characteristics and skills that are assumed to be markers of excellence in STEM. So that is most often things like being strong in mathematical abilities, being a logical and analytic thinker, and it's in contrast and being sort of brilliant and creative, but it's also in contrast to other things. It's in contrast to being relational and a good mentor and a good teacher. Often those things are seen as tangential or even in contrast to what it means to be an excellent science researcher or an engineering researcher. So that schema is about what counts as excellence, but also what is seen as tangential. And we certainly see that diversity concerns and interest in engagement and inclusion is actually seen as counter to excellence in STEM.
Can I chime in here, because it makes me think about not only the what counts, but like whose knowledge counts with respect to STEM and science and math. And I think about the work of my colleague Megan Bang, who studies native epistemologies in science and the ways that native ways of knowing science in some science classrooms get automatically discounted, which has implications for learners and for the development of scientific knowledge itself. So there's also this piece around how we're developing the knowledges of these disciplines that build on the range of cultural traditions, communities, historical traditions around knowledge building in those disciplines that we would want to really engage and support the growth of. And that in that, like narrowing what counts as value disciplinary knowledge, you also narrow who gets to be engaged learners in science and math spaces.
Another interesting question is there sort of a relationship between taking a growth mindset and racial literacy? And the degree to which you take an institutional growth mindset and the degree as it does that relate to sort of centering equity justice issues in institutions? Is there a correspondence between those things?
Yeah, I would say not automatically. I think this is something that we have learned in the course of studying and reconceptualizing mindset at this level, is that if we just talk about the growth of all students and the abilities of all students, that's helpful and different from what is assumed because of the cultural stereotypes about who has ability and who doesn't. But that what's best in these contexts are something we call these culturally inclusive mindset cultures, right? And these culturally inclusive cultures are those that really work to show how these ideas about fixed mindset have differential effects for students who belong to marginalized and structurally disadvantaged groups. And therefore, what the best strategies are that might be different by group membership of your students, right? And your student body attending to those concerns that students are going to differentially have based on their group membership and the cultural stereotypes tied to those in the classroom. So, we've done this project in K through 12 settings with Megan Bang, with Stephanie Freiberg, where we really had to show teachers and remind them about, their role as culture creators and how these cultures can have differential impact on their students. And so therefore, we talk a lot about what are the strategies that are going to not only communicate that everyone can grow, but that particularly, showcasing individuals from diverse backgrounds who have excelled in these various STEM fields, that's one of the ways in which we show we don't want this to be a colorblind growth mindset culture. It needs to be much more culturally inclusive, and it doesn't come automatically. It's something that I think really needs to be brought to the fore when teaching. And it's what we've done with the faculty in these college settings, is really show them. That's why we break down the data by disadvantaged group status, so that they for themselves can see where men and women are differing, where students of color and white students are differing, where students from disadvantaged groups are differing, and then what are the strategies that they can bring to bear when they have these various inequalities in their classroom. So I think that it's really important to do that from a structural perspective and very intentionally. I don't think that it automatically follows that growth mindset cultures are going to be equitable and culturally inclusive.
Mm-hmm. Another big and kind of classic question is, what would be a good goal for degrees of diversity in our institutions? What would be a goal? And is there some role that mindset plays in that? The way the questioner asked it is frequent responses when discussing parity. If parity, for example, is a goal, is that the pipeline is small. But there are many competent individuals passed over due to fixed mindset ideas. So is there some kind of connection between what we think of as possible goals for diversity, I suppose, diverse participation, and this role of mindsets?
Well, I can jump in on the kind of outcomes question, because it is, you're right. I like the way you frame that, Claude. It's a classic question. How do you know equity when you get there? What are you really shooting for with respect to diversity? I like to draw on a definition that Rochelle Gutierrez wrote about many years ago, which describes the failure to predict, right? That equity is when you cannot predict the outcome based on race, ethnicity, gender, social status, disability status, when everyone is equally likely to succeed or fail, irrespective of those characteristics. That's when you know you have equity. And that, I think, should be the goal when we think about diversity. I think, I think about representing a full, that you should represent the whole population, right? So if you are a university in California and you're thinking about how diverse should your student body be, it should represent the proportion of whatever the diversity levels are in California. Same for your faculty, right? So I think those are ambitious, but anything less is not really equity.
Mm-hmm. Yes, I have a sense that the idea of a fixed mindset, or of the fixed mindset, that ability is a fixed entity of some sort that sort of is God-given or genetically given, has a dark history. and we haven't really confronted it and tried to unravel it in relation to our educational institutions and the like. But it is rooted more in history than it is in scientific evidence. I think that's a fair statement to say, but it hangs out there as a kind of organizing idea with regard to so much of education. Just think about tracking and laning and various traditions that we tend to want to sort people based on almost magical ability that we think is in there somewhere. That's like an IQ or something. It's in there. I just know it's in there, and that's driving the bus. And I've got to get a handle on that in order to really be an efficient educator. Otherwise, I'm going to be using my resources inefficiently and so on. That's a deep cultural set of assumptions, which is at the root of so much of these difficulties that we're talking about with regard to diversifying STEM fields and the like.
Yeah, and you're right that those deep assumptions have been used then to divvy opportunity, right? To say these folks are worthy and these folks are not. I had an experience a few years ago, maybe 2 years ago, where I was at the American Academy of Arts and Sciences, which is in Cambridge, and it's it's an honor society across many different disciplines. And on the wall, they have pictures of the past presidents of the American Academy. And it goes back to like the 1700s, which is kind of phenomenal. The whole thing is kind of phenomenal. But the point is that the pictures on the wall, when you go back far enough, for the first, 200, 300 years are all white men. And then you wonder, like, it could not be the case that only white men were doing extraordinary artistic projects and thinking, and that's about opportunity, because it doesn't stand to any other reason. And so I think to your point, Claude, that these are notions that get used in particular ways that are about constructing and maintaining systems of privilege, and which is why when you start to dismantle them in schools through detracking, through other types of processes, you get major resistance, because then we don't know how to divvy the opportunity anymore, right?
Yeah.
Mm-hmm.
Yeah.
I think it's important. Oh, go ahead.
No, go ahead, Mary.
Go ahead. Oh, I was going to say, I think when we talk about pipeline, it's really important to be thinking about how, yes, people might leave the pipeline because they are attracted elsewhere. They don't want to persist in STEM. They find something else more interesting or more attractive. But also there's this huge role of pushing people out of the pipeline, right? And that the cultures of genius do that disproportionately to women, to people of color, to people with disabilities who are culturally stereotyped as not having this innate brilliance or idea or genius. And I just think we need to be making, when we talk about the pipeline issue, trying to figure out how much of this is sort of individuals of their own volition sort of making these choices versus how much of this is structurally based due to cultures of genius and other ideas that perniciously push people out of these contexts that they want to be in.
Yeah, I think it's
just
a great
quick thing to add there. I think that in addition to the concerns about who can be scientists and making and expanding that definition, we also have to push on the definition of what science is or what counts as science. And a really good example of this is a gay biology graduate student I interviewed who said that no one talks about all the fish that have 3 or 4 genders or 3 or 4 gender mating systems. That's not counted as real science. And so to study that, even with a standard scientific method, doesn't count as sort of rigorous science that meets the bar. And so in addition to expanding the pipeline, expanding what counts as science and engineering is really important for meeting the challenges of how science and engineering as professions can contribute to the social good and public welfare.
Yeah, we're drawing to an end, and I'm supposed to say something wise in summary about all these wonderful talks and conversations that you guys have had. The only thing I can think of any utility at all might be a distinction between what are sort of the basic components of a science, the methodology, the statistics, the computational strategies, These things I would be willing to grant are fairly objective, and you learn them. Yeah, they're the price, sort of price of the ticket in order to be a scientist and enter into a STEM field. But what we're missing, I think, and this is sort of an attempt to summarize so much of what you guys have been talking about, to put under an umbrella, is the idea that this culture of science and the agenda of science is set very subjectively. These things are set by the particular kinds of people who are doing the work, what they think of as good problems, what they think of as the nature of ability, and what they think of as the wisest approach to pedagogy at any given time. Those things are really quite subjective. They benefit from the gloss we have about science, that anything about it is objective. That is our hope. But really, in fact, a great deal of it is subjective and is composed. I used to joke about this way back when I was in graduate school, that I realized that to be a really good scientist, you had to like dry wine more than sweet wine, because that's what the good scientists liked. A little ridiculous, but it illustrates kind of what we're talking about here. It's just, there are the sort of extraneous features of the people that comprise the enterprise of science come to be seen as objective standards of the science, and who's really good at it and who's marginal at it. That is what we as an enterprise, science and scientists, that is what I think we need to get much more aware of. And that gets deeper at what the DNA of science is that makes it difficult for all groups to access it. A lot of the extraneous things. Maybe sweet wine drinkers could be just as good a physicists as dry wine drinkers, actually. Maybe in their own worlds and their own environments, they have had to develop some incredibly sophisticated cognitive skills that would bring a great deal of insight to some of the basic challenges that a science faces at any given time. But it's hard for us to see it because it's so lathered in the culture of the people who are scientists. And that culture gives privilege to those who are in it and disadvantage to those who are not in it. And I think as a diverse society, it's incumbent on us to begin to examine that as a real major issue in the future of our sciences as an enterprise. Well, I'm seeing we're just about out of time. Does anybody have any other final remarks they'd like to fit in at this point? Any other questions? There was one question of which I'll put out there, which this is from someone who asked, this is a very interesting discussion. How do I take this to high school level? What do I do at the level of high schools to benefit from some of the wisdoms that they've heard today? Any last conjectures about that?
I mean, I would just say that high school is the perfect place to enact many of these suggestions and ideas, because then it's at a time that's super critical for young people's developing both their math and science thinking skills and their identities as math and science thinkers and learners. So I think, thinking about how you do that both within the classroom and as you set up systems that are ideally heterogeneous, that encourage young people to take up really important conceptual problems and issues of the discipline, where it's not just kind of rote applying of formulas, and if you don't get it, you're wrong, but where you're really focusing on the nature of thinking and recognizing, again, the various types of contributions different students make to that conceptual work that happens inside the classroom.
Yeah, I'd add like a focus on the community of learners. Who are the how do you create a community of learners in the high school classroom? Many students are in these STEM classes in high school because they have to take them, right, along as part of the curriculum. And so how do we actually have folks who sort of are effortless achievers, bringing along individuals who are struggling? And how do we actually talk about struggle as actually so important for learning, crucial for learning, rather than something to be ashamed of, something to hide, right? How do we actually create contexts where people can learn together and grow over time? And I think that talking about how different ways of knowing are valued in the classroom, and that's how we get to less of the colorblindness and more around sort of what individual groups bring to the study and learning of science. I think that can be done in high school in some ways, more so than in college. And so I think that that's really powerful.
I'd agree. I really think it's important that high schools and even earlier are important to build a more inclusive culture around our sciences. I think the attention to that needs to be a real fundamental thing of focus of educators for a good while now. Well, I want to thank the panelists who did an amazing, wonderful job of squeezing into a brief period of time some amazing ideas and data and evidence. And I hope it's been useful to the audience. I feel it's been very useful to me, so I can speak for myself in that regard. And thank you, and remind everybody that this has been recorded and will be available. I think I said it earlier, on socialsciencespace.com. It will be available soon that way, so you can return to it. In the meantime, thanks again to the panelists, and thanks for the audience for hanging in here. We appreciate it.